Here is a box of water vapor. Decrease in temperature means decrease in kinetic energy, resulting in change in states. Then what will happen if the temperature gets extremely low that the particles have no kinetic energy at all? And that is what we call an absolute zero. In absolute zero, there is no more energy left to take away, so particles doesn't move at all. There are no kinetic energy and no movements. Then, is it possible to reach absolute zero? Well, sadly, no. The third law of thermodynamics states that the closer you get, the harder it is to remove the last tiny bit of energy. Well, the scientists have gotten really close to absolute zero, which is just a few billions of Kelvin above it. They use laser cooling method to cool down the particles and to reach absolute zero. The laser tuned slightly below the atom's absorption frequency is shot. If the atom is moving towards the laser, it perceives the light as slightly higher frequency. For example, when an ambulance is moving, the sound wave in front of it gets compressed and behind it gets loose. Therefore, it is higher pitch as it approaches, and this is called Doppler effect. The atom absorbs the photon, then it re-emits the photon in a random direction. So an overall kinetic energy of an atom decreases. But what if absolute zero was actually reached? Then everything will stop completely. There will be no thermal energy, no movement, and no vibration. However, quantum mechanics says there is always a baseline energy called zero-point energy. So, even at absolute zero, atoms will still have faint quantum jiggle. If absolute zero could be used in daily life, it would be useful for quantum simulation, electricity with no resistance, and more.